That's hi everyone. It's the last couple of days, so I'm glad you guys are here. Those who are still staying. I'm talking on Premiere a little bit. So for the first, a little bit about me. My name is Droidcon. I'm the director of a company called Plus Productions. We have a booth outside. You guys want to talk to us. And this URL right here, Droidcon. This is where you'll be able to find links to GitHub, slides, and all that. At the end, I'll be posting those probably tonight. So first up, Google Fit is still very much in beta. So it's not been completely valid. So anything I say can change in the future. But this is a first dive into what I've seen so far in using Google Fit. So what do you get out of the box? Google Fit data can be categorized into three things: body data, activity data, location data. Body data contains things like weight, height, heart rate, activity data, calories, cadence, things you're doing. And location, speed, location, and distance. This is what you get out of the box. It's not all that much to begin with, but it's a good start so far. Getting started. So right now you have to install the preview, which is version 81 of preview. So you just follow the instructions on this site, the preview page to download the version. And one of the things you're going to need is an API key. Currently, you don't need this for actually testing the data, but once this is public, you're going to need an API key, just like you would need for Google Maps and any other Google Play services. And connecting to Fit is just like any other Google Play API. Just put in your fitness API. Body data, activity data, location data. This is where you specify you want to be able to read body data, you want to read location data, you want to read activity data, and you have to request either read or read write, depending on what your application is doing. And this is, authenticating with the API. Alright, so now that the basic stuff is out of the way, let's get into much bigger, better overview of what Google Fit is. So Google Fit is a universal data source. What this means is, it's a database for your fitness data. You can read from it, you can write to it. It's also a central sensor hub. The API wraps around sensors to give you more accurate data. Accurate data might not be the right word there, but data, it's picking all the sensors to give access to and giving you how they relate to your fitness. So they might be, the gyroscope, for example, is being taken and you don't get the raw gyroscope data, you get the processed gyroscope data to kind of give you like a cadence, for example, or steps. If you don't have a step counter per second. As I was saying, there's not too many links to it, but there are. The fitness guy is accessibility. You can create your own sensor, you can create your own custom data types. So, and the custom data type can be both private or shareable with the public. So, like if you have a blood pressure monitor, glucose monitor, you can make that sensor available with the sensor API to other apps. If you make that data type available publicly. Currently, you have to get approval from Google to make your data type shareable. And this link right here will show you what you need to do to make that happen. It's literally put in proper package naming, explanations of why you're trying to fix that out, and Google has to this again. Your admin interacts with them as hardware sensors. How it's actually implemented, it could actually be using hardware, but that doesn't, the underlying implementation is just sensory, the software sensor. So let's go into, before we go into like talking about how to read or write data, right now, let's talk about custom data types, because by learning this, I can actually teach you guys how reading normal data, the ones that Google provides already, and reading your own custom data, it's slightly different. So this is how you would define a custom data. So first off, you need to make sure your package name is part of the data type. Technically, you don't need to do that, but they kind of suggest that you do it this way, just to make sure it's all data types are separate from each other. Because again, multiple apps can be reading and writing, so the same could be writing, if the data type isn't public for some reason, you could be writing the same data type, if everyone called it blood pressure, there'll be confusion. So, it's a good practice. I highlighted fitness here because if you actually look at the documentation, they just kind of go history, you have read data type. But all those variables are actually part of the fitness. So you have to make sure you have fitness. For there, then you can add your fields. So fields can either be formatted integers or floats. And you can name the fields whatever. You can also add standard fields. So like here we're adding solid, and beat per minute for heart rate. And so two of them are custom, the third one is a standard field. One thing you should know, everything, there's on the bottom of these slides, there's an activity there, that you do that activity in Java. In the source code that will be uploaded, those are the classes where you find these exact implementations, so that you can see how it relates more in depth. It's right here, we're just covering some of the high level points first. Alright, so now that we can create custom data, so universal data source, you can read, you can write data, this gets saved in the cloud, which actually doesn't seem to be working currently. I assume since it's a beta, they only work locally. As a note, I was trying to get two of my devices to read the same data, it wasn't working. So right now, the cloud part of it isn't there. But theoretically, those will do it. And it's not app-centric, it's user-centric. So if your app needs to get the weight of a person, instead of creating a UI to have a person enter their weight, just read it off Google Fit. User might have another app that they're using, and you can streamline their login or the creation of accounts if you need that kind of information. So there's things like that do. High level, how is the data organized? So all data comes from data sources. Sensitive data sources, active data sources. The data itself is the data point, and you get that back as a set of data. So it's basically an array list of data. And you can interact with that as sessions or buckets. Sessions are some bucket of some session of time. So if you're biking for 1 hour, that would be a session. A bucket is different. That is how you can query data from Google Fit. So if you're just trying to get all the data per day for a user, you can query, give me the bucket by days, and it'll give you all the data points as buckets for each individual day for the duration of time you ask for. And you interact with the data source through the history API. So reading data. You basically created this data read request, and you specify what specific data source you want. there's a couple methods to this. The default, the easy one, and one most people will probably use is the add default data source. If you're just trying to, if you're trying to make your user account creation or something streamlined and you need like a wait a night or something like that, default data source is all you need, because that will give you every app, any access to any app that gives you the heart rate or gives you the higher rate. There's also other methods like aggregate data source, which will only return you things that give you sessions, for example. So you can specify a little bit what kind of data, how much you want, and then you can bucket it by time or by other units. Time is probably one of the ones people often use in that, so after this one here. You can specify the time range for data for the last 2 minutes or the last 2 days. And that's been long, some of those times. And then you request that data, you get a end result, which you can then add all that to. And you either get data that has pure data sets or buckets. So if you ask for buckets, you get buckets. If you ask for data sets, you get data sets. Sorry, if you ask for no buckets, you just get data sets. And writing data. Actually, let's go back here. Where you set the custom data source, you can specify your custom data type here, and you'll start reading from your custom data. So it's really, nothing really changes when you work with custom data versus standard data. And then reading data, you start writing data. Same thing, you set the custom data you're trying to write. And you also set the names. What is the source name? So first let's create the data source. So you set the name to this, you set the package name. So your app, you're trying to write something, you would need to create yourself, you would need to make yourself a data source. Or your sensor, you would need to make yourself a data source. And name yourself. And writing data, you then use that data source you created to create a data set, and then you can add a data point to it. So you timestamp your data set. So there's these methods, settings, values, load values are really helpful if you happen to be using all ins or all floats for your custom data, or for any of the standard events. But if you're not, like in the case of the low pressure one, where I have 2 of those ins and 1 float, you have to put these manually, and they're all set in specific order. So the way I specify was solid, that's solid, and that's perfect. So 0, 1 are solid, that's solid, and then the third ones I can actually use the default fields. There's no way to access them by name. It's only through index. And then for actually inserting data, you just create a data insert request for that data set you created. Save. I didn't get a chance to work with sessions too much yet, but here's the high level of how things change a little bit as you're working with sessions. From the history API, when you're working with sessions, you're inserting, you create insert requests as opposed to a session insert request as opposed to a data read request. Sorry, data write request. And if you're reading, you create a session read request as opposed to a data read request. And then you get back, instead of buckets or data sets, you will get back sessions, an array of sessions. And if you're working with the recording API, the recording API is used if you're creating a sensor and your sensor is actively, continuously writing data. The history API is used if you're just doing like one-offs. And then you start a session, you end a session. While the session is started, any data points that are being saved are being attributed to the session that's currently running until you close that session. Now a little bit about the central sensor node. That's what I call it. Using basically the sensor API, you can request access to any hardware sensor, any software sensors the device has access to. You can also request ELE support sensors for some data types. Android Wear, all the Android Wear devices out there, and any sensors those things have, you'll have access to all of them out of the box with the BLE API. So you interact with sensors through two APIs, sensor API and BLE API. If you want to update your research in real time, of like data that's currently being recorded, you have to use the sensor API. You can't use the recording API or the history API. Those don't get updated. These can continuously get updated while you're using them. So that's the only way to keep your users up to date with what's going on. And separately from recording. So working with sensors. Same thing as everything else, you have to make a request. You have to create a data source request. So you're telling the system, find me any sensors that support the heart rate in this case. And you can set what kind of source you want. So like type raw means I want the raw values. There's also aggregate, which means they'll give you like average values over a period of some time. And you can specify more granularly what kind of time you want there. Then you find this, and then you start finding the looks for them. Once you have a data source, you can then request access to that sensor. And that data source, the set data source, that's where you would use the data source that came back in the previous call. And you can set a sample rate for out if you want to be updated. And then you register. If you're working with BLE, same, you have, instead of using a sensor request or previous request, you use a BLE sensor request, and it'll start looking for any BLE devices that are attributed to that data. So that BLE API is pretty similar. It's just, instead of using one API, which I think they probably could have done, you have to use two different APIs if you want to interact with BLE devices particularly. Alright, so creating custom sensors. Overall, it's actually really easy. You can create a custom sensor by adding this intent filter for any service. Your service has to extend application sensor service and implement these four methods. Here's the catch component, at least for, in the case for right now, for the app I made for demo, where I'm using a custom data tape for blood pressure. The sensor, you can't use a custom sensor for a custom data type unless your custom data type is already built. So there's a catch there. Otherwise, for normal data types, you should set the type name of the data type and during the upgrade process, we would, back to what we were saying before, when inserting data, you have to create a data source first, name yourself the data source. During the upgrade, you would create that data source. During the find data sources, which if you noted it's a couple slides back, that when you're requesting a sensor, you're calling the sensor API and find data sources. When that gets called, your service will also call for find data sources. And what's happening here is you're trying any custom data type you support. If you support the custom data type, you return an array list of data sources that you do support for the request that we just made. Once those data sources are returned, and the developer then registers for your sensor, you would get the register call. And when they unregister, you'll get the unregister. Application sensor request is the key part here for publishing data. When you get that and you create your data point, the application sensor request has a dispatcher where it's published. And so as you're getting the update to your sensor, you would be publishing this. And that's pretty much how it senses the basics of the sensor. You can interact with hardware sensors as well, but that's beyond the scope of this conversation. If you want to talk about BLE sensors or any of that stuff, some of the other BLE talks maybe be probably a good place to learn on that. I did have a demo, but my emulator, every single time I try to log into my Gmail account, which is required to log in, obviously, just crashed. So if you guys want to see it, come over to our booth. I'm more happy to show you guys the demo. And here are some public links. So there's the preview, the developer preview page, there's the samples, they have a couple samples themselves. They're not that easy to understand in my opinion. There's just too much going on. I tried to make my sample a little cleaner and cut it up into smaller bite-sized chunks. So like connecting with the Fit API is one activity, bringing custom data types is a different activity. It's just using extensions, subclassing to break it down into smaller pieces so that you guys everyone can see, all right, so this is how you do this part and this part. As I said, I'll be publishing the book source tonight, and all the links will be available on fuzzle.pro/Droidcon. There's also a Google Plus community for Google Fit. There's not too much in there anymore, but more people start using it, there's going to be a lot of stuff there. Any questions? Okay. You can use this API if Fitbit was supporting the sensor API for Google Fit. So there's a requirement that the hardware and sensor makers and all that are as a VDO device for Google Fit. So yes and no, it all depends on whether Fitbit actually supports it once this is out. Since it's all on Google Play services, back to 2.3, 2.2 basically. Granted, I hope most people are running 4.0 at this point. Yep. Applications are pushed, that's actually interesting test. I haven't tested for multiple things that we publish into the same thing. And everything has timestamps, and so I imagine you could probably just read out a data source. So that's why all data is reported to Fit is always tagged with the data source it came from. So you can specify, like, I only want data from the Fitbit app, or I only want data from the Moves app if they're reporting it, and I don't care about any other set data. So it shouldn't double. You just need to read out which data source you want. Yes, so that was one of the parts of the demo. So you can enter data and just record it using the reporting history API. And you just tag your app. You create a data source for your app, and your app is the source for that data. would allow you to get continuous data, and if you set the limit to like 10 minutes, which I suppose should be fine. As for that particular case, there's also other parts for workflow sessions. You can add activity segments. And you can, so if you were going at a certain pace for running, for example, you might have an activity segment for running at 6 miles per hour. Then you might create another activity segment for when walking 3 miles per hour after that. And then another one for when you start running again at 6 miles per hour. So you can use sessions to kind of get some of that information. If you're writing data, it's going to be going to the cloud. It's the cloud. If you're reading data, you're going to be reading into the cloud, or anything that's locally stored or written on the device. There's all the cloud data is also stored on the device locally, so it's written to the cloud. In the fitbit case, you could have here, but you would be using a sensor API at that point. If you're using the discrete API, you would only be able to do it to the cloud. If you're writing, you can do it through the recording API, which would take live data as it's coming in. Yes, not completely every actually. But so you request by scope, and the scopes are activity data, buy data, location data, and you can do read, write, or and the user can control if they want you to access that particular scope, or they don't want you to write access, they can request for access, but they do want you to read access on it. They can do that kind of stuff, but it's all based on scope. So you either get all of it or nothing. There are no permissions and there are no additional features or anything you need to actually manifest. These are permissions in the world of Google Play. Sorry, say we have no control on that. I imagine Google is adding some encryption there, since this is personal fitness data. That's it's just like any other, you go to your doctor, all that's private and personal. So I would hope they have encryption data there. One would assume, at least. Correct. One of my professor productions, we're also giving a common automation and expression tomorrow if anyone's interested. That's all for the fit.